So this is leveraging the ability of ACI to rewrite the destination MAC and put traffic on a different bridge domain than the one where the source and destination are. Now, before you start with the deployment, this is a summary of what are the key preparation steps. So the first point that is important to know is that ACI must be the default gateway for the servers. So the BD subnet IP of ACI is the default gateway for the servers and not the firewall or the load balancer. The VRF and the bridge domains, where you have the endpoints connected, so the clients and the servers, don't need any modifications in order to be configured to steer traffic through a firewall. And it's very different from classic service insertion. Then you can choose whether you want to place the layer 4 device directly into the bridge domain of the clients and the servers, or if you want it to be on a dedicated service bridge domain. And this presentation uses a separate service bridge domain. Then you want to decide whether you're going to deploy this device in routed mode or in layer 2 mode. And this presentation focuses on the integration in routed mode. You need to define naming conventions, and although the object model of ACI is flexible enough to accept the more different kind of names you want to give to the objects, you should be careful for service graph purposes to avoid using -n and -c. So if you need to concatenate different terms in the name, we suggest that you use the underscore instead of the dash. If you decide to integrate layer 4, layer 7 by using a virtual appliance, we suggest you consider integrating it via a VMM domain. And then if you're using AVS or AVE, you can choose, of course, VLAN mode. But if you use VXLAN mode, you need to define also VLAN pool because the interfaces from the services devices use VLANs. Then you need to decide if you want to use a layer 4, layer 7 device in 1-arm mode or 2-arms mode. And this presentation focuses on the insertion of a device in 2-arms mode. Then you need to make sure that for redundancy purposes, the service device that fails over uses the same MAC as the device that was primary before. So basically, you need to have a floating MAC address. And this goes under different names. In case of F5, it is called MAC masquerade. In case of firepower, it's a virtual MAC address. In case of checkpoint, it's a VMAC, etc. And then you need to decide which side of the graph should be the consumer or the provider side. This is most of the time completely arbitrary. You can choose whatever you want. But you need to be careful with multi-site, where you have inter-VRF traffic, and specifically for north to south traffic, the layer 3 out in this case must be a provider and not a consumer. What are the PBR requirements? Minimum release that you need to use is 2.01m. PBR is for both virtual and physical appliances. It can be used for traffic between EPGs, between a layer 3 out and EPGs, or even between layer 3 outs themselves. PBR is available also for multi-pod, multi-site. The Keep Alive feature is available from version 2.2.3 and 3.2.1 or later. The traffic can be steered to the device is unicast traffic and not multicast traffic, nor broadcast traffic. You have to connect the device to a bridge domain. You cannot use a layer 3 out as a connectivity point for the layer 4 device when you need to redirect to this layer 4 device interface. So let's now go into the key part of this presentation. So first step, create service bridge domains where you associate the consumer side and provider side interfaces of the layer 4 device. These bridge domains must have a relation with a VRF, and this VRF must be the VRF that the client and the servers are using. If the contract is between different VRFs, the service bridge domains must associate with either VRF. The BD can be configured for hardware proxy or a non-Unicast flooding. IP routing must be on. A subnet must be defined, and the subnet it's where the routes of the firewall point to. So the route towards the outside for the firewall points to the subnet on this bridge domain, and the route to the web servers from the firewall points to the bridge domain IP of the service BD number 2. And then you do not need to turn off data plane learning, although this was required for releases prior to 3.1, and it's required if you're using first generation leaves. Step number 2, that's where you need to create the redirect policies. So that's where you define the destination IP and MAC addresses for redirected traffic. And because here we're using a 2-node deployment, there will be one for the outside interface and one policy for the inside interface. And the MAC should be a floating MAC. Like we said before, the same MAC should be preserved upon failover between the primary and the firewall that becomes primary after a failover. Step number 3, you need to define the layer 4 devices that are part of the same cluster in the graph. So here we're defining a virtual firewall, okay, a virtual ASA, and so we define the mapping for the interfaces that we're going to call inside and outside. So this slide doesn't show it, but inside is mapped to a network adapter, and the outside is mapped to another network adapter of the same virtual appliance. This is virtual appliance number 2. And the same story, you have inside and outside mapped to different network adapters. And then these are the cluster interfaces. So in the configurations of the graph, you reference only the cluster interface, meaning the interface that represents both the outside interfaces of the 2 firewall and the interface that represents both of the inside interfaces of the firewall. Then you need to define the graph template. The graph template says that the previously defined cluster of devices is between a consumer and a provider connectors, or consumer provider EPGs, and that it should be configured by a redirect. But one of the key steps that needs to be performed is the association with the graph template with a contract subject. And so the contract could be predefined, or you could define a new one. And in the subject, you may have a subject for all the traffic, all the IP traffic, or it could be a subject for just, say, a set of ports for 80, for 443, and so on. So this is what you see when you do apply a contract. You need to choose the EPGs for the external network or the consumer EPG, EPG for the provider network or the internal EPG. And then you would choose, in this case, an existing contract subject. The contract doesn't have to be between 2 EPGs all the time. It could also be between a layer 3 out and EPG. If you're using a deployment of a service device in 2 arms mode, so with an outside and inside, like in these examples, you need to make sure that one side is consumer and one is provider. If you provide and consume the same contract, then you cannot apply the configuration because ACI will not know anymore which is the consumer side service bridge domain and which is the provider side service bridge domains. Make sure one side is provider and one side is consumer. And then do not use common default, because this will also redirect ARP, not just IP traffic. So ACI then will ask you information about the service bridge domains for the consumer side, so for the provider and the consumer. The redirect policy, so these are the policies that we defined before. So this is the one that redirects to the outside interface of the firewall with a given MAC, and this is the redirect policy that redirects to the inside of the firewall, to the interface MAC of the firewall. So ACI will use this information to do all the stitching that is required. And so this is what ACI is going to do. It's going to create port groups to attach the for device interfaces. It's going to move the VNICs to the correct port groups. It's going to match the VLANs, and it's going to program the policy cam with the outside and inside EPGs so as to perform the redirection. Now, you don't have to always configure redirection for both directions, for both interfaces of the firewall. You could also have PBR just for one interface, because, for instance, if the firewall does not on one interface, you need PBR only on the other interface, for instance. Direct connect is an option that you need to choose when you need to send traffic to the firewall IP address over an interface that is used for service graph redirect. Because what this does, it configures a contract to allow traffic to the firewall itself. Normally, traffic will get to the firewall because of redirect, not because of direct routing. And so this option modifies the programming of the policy cam so that between the implicitly created EPGs that ACI creates and the EPG where the traffic is coming from, it ensures that there is a permit entry, which otherwise would not be there, okay? If you need to have more information, you can reference this great white paper, which has all the details about policy-based redirect.